Hi everyone! My name is Alyssa Valise and I am a fourth year electromechanical engineering student at Wentworth. I grew up in San Diego, California, which is where I'm recording this video from. I'm here for the time being because of the coronavirus situation, but we still wanted to make sure that you guys are getting some useful information in place of your accepted students day so that you're making the most informed decision about where you want to go to college next year. So I'm really excited to be able to use this opportunity to tell you guys about a project on campus that I'm really passionate about. I'm the team president. It's consumed my life for the past 3 years, and I'm really excited to tell you guys about it. And hopefully this information inspires a few of you to come to Wentworth and maybe even join WUROV once you get to campus in the fall. So presenting WUROV. Okay, so WUROV, it stands for the WIT Underwater Remotely Operated Vehicle. It is an IEEE project. And I'm going to start this presentation by just defining what exactly that means. So that WUROV is a bit of a weird acronym, but ROV is actually an industry acronym, and it stands for Remotely Operated Vehicles, ROVs, and they are submersible machines capable of semi-automatic motion and control. There's other types of submersible machines. There's AUVs, which are autonomous underwater vehicles. When it's completely automatic motion and control, there's no human interaction with the robot at all. There's HOVs, where there's a human being actually in the robot controlling it while it's exploring the ocean floors. We again work with ROVs, which are remotely operated vehicles. Imagine a human being on a ship or on the shore controlling the robot via a tether connection and camera feeds coming up the tether. The tether is responsible for providing power and connection. They're commonly used in underwater exploration and excavation projects. So whenever we need information or to explore or to collect things from places that people in wetsuits can't survive due to pressure and temperature differences, we'll send an ROV down. They're used all the time in pop culture and in the real world. If you've seen the Titanic by James Cameron, the machine that they're using to explore the sunken ship is an ROV. We also use ROV technology to locate a lost hydrogen bomb in the 70s. So these things are used all the time, and they're really cool. There's a lot of really cool organizations that do great work with ROVs. We work with the MATE organization. MATE stands for the Marine Advanced Technology Education Organization. They run out of the Monterey Bay Aquarium in California. So if you've participated in VEX or FIRST or anything like that, this is kind of the organization that provides our game to us. They put out a request for proposals, which is kind of like our game manual, just a more collegiate level version of that. And we are just responsible for designing an ROV that can meet that request for proposals. So they'll give us a list of tasks, a list of challenges, and we have to design a system that is capable of completing those tasks and challenges. MATE is responsible for the orchestration of the MATE International ROV competition, which is the goal of our project, is to qualify for that competition and compete successfully at that competition. About 800 teams from around the world register for this competition every year, and only 80 qualify. Of those 80 teams, only about a fourth are from the United States. So it's a hugely international competition. It's hugely competitive, and we're really proud to have qualified for a few times in the past. So I did run out of IEEE. IEEE, if you're not familiar with them, they're a national organization in the United States of America. They stand for the Institute for Electrical and Electronics Engineers. We are the student chapter of IEEE at Wentworth. As the student chapter, we have qualified for the MATE International ROV competition 3 times, and we're really proud of that. So if any of you are getting turned off at all by the electrical and electronics part of this, I said that I'm an electromechanical engineer this year, and we are hugely interdisciplinary, and it's not exclusive to electrical and electronics engineers. We have students of every major, every background, and we're really proud to have a team of actually way more than are in this picture. We have a team of about 52 students right now, which is just phenomenal. Of those, We have a bunch of different majors. You'll see there's a lot of electromechanical engineering and some interdisciplinary engineering, but we also have students from business, computer networking, biomedical engineering, computer science, computer engineering, electrical engineering, mechanical engineering. We've had industrial designers in the past join on board. So again, it's hugely interdisciplinary and hugely collaborative, and we're really, really proud of that. It's also a really great mix of female to male and non-binary students on the team. Wentworth's female to male ratio, I believe, is at like 19 to 81% right now, and ours is a lot better than that. We try to be a really supportive and inclusive group, and I'm really proud that our self-identified female group right now is 26.8% of the team, which is just fantastic. So. We also have a really great mix of year of graduation amongst our students, so this project is not dying off anytime soon. Our biggest group of students is actually graduating in 2023. So there's a huge group of underclassmen that are just as passionate about this project as I am, and they will be here in the fall if you decide to join. So we operate on 3 principles at WUROV, one of which applied leadership. We kind of replicate a corporate leadership environment. I'm the CEO of the project. My good friend Nick Stratton is the CTO. We have VPs, a VP of mechanical engineering, a VP of electrical engineering, and a VP of software engineering. Rookies and underclassmen are given all sorts of opportunities to take lead and to apply leadership. They're given point on small projects. When you join the team, you might be overwhelmed. Most of us are. I definitely was and still am. We have an annual rookie challenge for all of our new students where they're immediately asked to design something from scratch. And while grades are really great in a classroom setting, the lack of traditional grading or pay force personal accountability within the team and a passion for lifelong learning outside of the classroom and outside of a required learning environment. Upperclassmen are responsible for how long this project lasts, and that means that they really understand the importance of paying it back to our we're really proud as upperclassmen at this point of what we've created, and we're really excited to see what the team in the next few years. It's students teaching students on this project, which is unlike a lot of other things that you'll find in your collegiate experience. So we're really proud of that. Next principle is interdisciplinary collaboration. I've already touched on this. We've got 9 individual majors on this team. We've got collaboration with faculty, staff, external collaborators. We work with SME pretty regularly. There's students from ASME on our project. This ROV is constructed in just about every single building on campus. So every department knows about our project. Every single manufacturing space has helped with this project in some way or another. And we're really proud of that because that's how real engineering is. Just working with people that are your major. You're never just working with people that are your discipline. You're always going to be learning from others and having to collaborate and learn with people that are skilled in different things than you are. So proud of this interdisciplinary collaboration. Lindsay is one of our freshmen this year, and she's in the photo. She's a biomedical engineering student, and she's taken the lead on a lot of our electrical engineering projects this year. So we're really proud of her and that do the same thing. Our last principle is project-based learning. This might sound really cliche or simple, but it's really true and it's really important. There's certain things that you're just not going to get the opportunity to learn in class. There's no way that they can fit all of it into our curriculum. And we're really proud to provide an environment where students can learn hands-on skills like KiCad, SolidWorks, and really apply it to a project that they're passionate about. It improves students' attitude towards their education. I know that ROV has made me much more passionate about my classes because I'm able to take the knowledge that I learn in class and apply it at ROV. So I really love this aspect of it. And students can use this project on their resumes, in their careers. I know so many of our students have taken things that they've done at ROV with them to interviews at companies. I also heard that Wentworth requires that students participate in projects as part of our curriculum. Electromechanical engineers have freshman, junior, and 5th year design projects. Every other engineering majors have freshman year and senior design projects, and students are able to use parts of ROV for their classroom learning. So you could also parlay this into your education, your traditional academic education as well, which is what a few of us did last year, and we've had a lot of other groups do it as well. So challenges that we face as a team, pay attention to these, and if any of them interest you or inspire you, please feel free to email me, and I'll try and get you set up with someone that could get you learning about it before you even get to campus. So number one, we have the mechanical sub-team. They are responsible for the mechanical design of the robot, manufacturing the vessel, and system integration and assembly. So all the subsystems, all the different manipulators that need to get put on the machine, they're responsible for. Some technical challenges that are really exciting and hard and fun are waterproofing electronics up to 5 meters. I know that's a really specific challenge, and it's fun and hard, and we really love solving it. Modularity is really important because the actual system needs to last for years. So creating a system that's modular for years to come is really important. And custom manufacturing, every single part on this robot was designed, built, and manufactured by students on campus. So having to design within those boundaries is really important and something that is really so this is what our 2020 machine looks like. Unfortunately, our competition was canceled due to the situation with the global pandemic, but it was doing really well, and we were really excited about it, and it's really beautiful, and we're excited to be able to use it next year. So that's a photo of the ROV swimming in the Simmons Athletic Pool. And that's a photo of me machining something. The next big challenge that we face is within the electrical sub-team. So they're responsible for the conception and design of all electrical connections, circuits, and components required for control and power. So if you've participated in any other type of robotics competition, there's a lot of competitions that provide electronics for you. We have to design our own. So we're designing our own boards from scratch and having them built and sent back to us. So technical challenges involve converting high power voltages, providing stable connections, and designing PCBs. This is our modular electrical backplane. Students designed every single one of those boards from scratch on their computer, which is just so impressive to me. And I'm really proud of what they've done. It's really phenomenal. We're really proud of our electrical sub-team. And our last big technical challenge is within the software sub-team. They're responsible for providing control and feedback between the vehicle and its operator. They communicate through ROS, which is the Robot Operating System. It's an industry standard for robotics, so if you're interested in getting familiar with that software, please reach out. Control looping is really important when you're trying to fine-tune things underwater, and they move in 5 axes of movement, and they use OpenCV vision processing. So really cool stuff, really cutting edge standards. There's always a software guy or girl on the computer while the robot is swimming, and we're really proud of our people. They do a lot of really good work. Logistical challenges, if you're not struck by any of the technical stuff, but you're interested in any of this, we need help with it as well. Funding a project of this size is not easy. We have to apply for grants, we have to do fundraising, we have to reach out to people, and as the team has grown, workspace has become a pretty big challenge as well. We have our own space on campus, which we're really proud of. Their only student-run workspace on campus is actually IEEE's workspace. And fitting into it, it's kind of like our cozy little home. It's in the attic of one of our academic buildings. We really love it. So the impact that this project has on our students is immeasurable, but I'm an engineer, so I've tried to measure it. Our co-op at the most impressive places. Good friends of mine, teammates of mine have gone off to co-op or work full-time at places like Woods Hole Oceanographic Institute, working with real ROVs, NASA, Jacobs, Amazon Robotics, Harmonic Drive, laboratories, Method Machine Tools, Integris, Hydroid, another real ROV system company. So we're really proud of where our students are able to go, and all of them say that the experiences that they've had at ROV either landed them their co-op or greatly provided them help through their co-op. Our students really love being a part of the team, and we're really happy to be able to provide an environment where students feel supported and encouraged to learn at their own pace. There's all sorts of really cool opportunities for students to thrive and to excel, and we're really proud to be able to offer that environment for them. Future plans, like I mentioned, our competition was canceled for the 2020 season because of the coronavirus. But we're really excited about what this means for us long term. We have a really solid system that was ready for the 2020 competition, and we're going to be able to take that system and use it in 2021. So if you join the team in the fall, you're going to have a huge head start because of all the work that people did this last year, which is a blessing in disguise, maybe. So that'll be really, really great for us. If you're interested in being involved with any of this, please reach out. We're always looking for new students. And if you have any questions, we'd love to answer them. You can reach out to us at ieee@wit.edu. We have a website, we have Facebook, and if you DM us on Instagram, we'll get back to you there as well. So those are all of our points of contact. Thank you so much. I hope that you're enjoying your virtual accepted students days. And I'm sorry about your senior years. Hopefully you're all still having fun while staying safe. So hope to see you on campus next year. Again, my name is Alyssa Valise. Let me know if I can help you with anything ever. Have a great rest of your day. Bye, everyone.